Plenoptic, or Lightfield, cameras offer remarkable new possibilities for digital imaging. Unfortunately, Lightfield photography has had one limiting drawback, namely extremely low resolution of the rendered images. This low resolution is a direct consequence of the microlenses not being focused on the object, but on optical infinity. In this video, we are going to demonstrate how a simple modification to the lens placement in a plenoptic camera can bring its resolution back in line with expectations of modern photography. Here is a diagram of a traditional plenoptic camera. The microlenses are placed in the image plane of the main lens. They are not focused on the object being imaged. Rather, they are focused at infinity. As a result, the traditional plenoptic camera captures pure angular information for the radiance at each microlens. Here is a diagram of our modified, focused plenoptic camera. We have created the focused plenoptic camera by modifying the traditional plenoptic camera in the following way. We move the microlenses away from the image plane so that they act like micro cameras, focused on the object we intend to image. While this modification is slight in terms of how far the microlenses are moved, as we will see, the result is an extraordinary increase in resolution. Now, let's look at a series of images that compare traditional light field rendering with a traditional plenoptic camera to full resolution rendering with a focused plenoptic camera. Using the Fourier slice refocusing technique, we can create images that are focused on different parts of the scene. Although refocusing like this is a powerful capability, we can see that the resolution of the image is not very good. When we zoom in to look at the curb, for instance, we can only see a very blurred area where the curb number would be. Now, if we instead render this image taking advantage of the power of the focused plenoptic camera and the new way of rendering, we get an extraordinary improvement in resolution. For instance, the number on the curb is clearly readable now. We call our method full resolution light field rendering. Based on the new, more efficient sampling of the radiance, we are able to increase the final image resolution by 500 times in this example. Even larger increases in resolution are possible. This video was created from one single snapshot. Both traditional and full resolution rendering were done using the same data image. A brief explanation of the focused plenoptic camera is this. In the modified camera, we use the main lens to place the image of the object being photographed in front of the microlenses. With this arrangement, the common main lens acts as the objective lens in a telescope. The microlenses then act as multiple eyepieces and are able to focus on parts of the object rather than on infinity. This precise focusing is the reason for the much higher resolution achieved. The significance of this new approach is that it allows using current digital sensors in light field photography, but yet achieve final image resolutions in the range of 5 to 10 megapixels. As a result, light field photography is much more practical and acceptable to mainstream photographers. For further details, we refer you to our paper.